Thanks, Satya. So we've had some good points. So we have a point about organizational agility as a challenge, the buy-in as a challenge. So Velu, like, what are your views on the challenges organization face with data science?
Okay, I have been listening to him and then thinking through what kind of points that I wanted to really share here, right? I would like to really recall some of our interactions with our customers where, selling the data science, the ROI that the leader will get out of implementing a data science project is really difficult. I reflect that. And we have also gone through that struggling periods, okay? But when I see the spectrum of customers, right, it is not just the one or two customers, hundreds and thousands of customers, right, where I see different customers or different leaders have adopted data science at a different degree or different levels. There are some customers who are extremely matured in adopting a big data project or a data science project, and they know the nitty-gritties, right, ifs and buts of that world, so they know what is that they will have to do, okay? But while we see extremely matured players in the market, on the other side, there are people or there are customers who are still struggling to get into the data world, the big data world or the associated analytics. So selling them the ROI out of data science project is very tough. But once you crack that, right, for example, even if the leader is sold, right, but then when it comes to execution, there are lots and lots of challenges. Even in big players, these challenges are there, but the thing is, they have gone through that, they have built solutions to solve those challenges, and they are kind of equipped to handle those challenges on a daily manner or business as usual part, right? But there are the small players or who entered into the journey of data science or digital or IoT or all these analytics, right? They struggle a lot because they are kind of setting their infrastructure, moving the data and building the data warehouse. It's called a data lake in big data parlance, not the data warehouse. And then they build the analytic solutions, build the hypothesis, right, to solve the problem, right, and then build the solutions, models, implement it in the production, and then capture the feedback of those models, right? In all these phases, right, they go through lots of challenges. Okay, one of the major issues or the challenges that they go through is once they build the kind of data lake, right, exposing the data to the wider audience, especially data scientists, right, it's a major challenge. Data governance comes into picture, and all the leaders who have built strong data lakes with thousands, petascale data, right, they are much worried in exposing them. What will happen to my compliance or the regulatory compliances that I am supposed to follow if I open up the data lake to a wide variety of users, especially data scientists, right? They need access to all data, right? It is not like I can take some 10 data sets, give it to them to build the analytics model. It is very wider and deeper in perspectives, right? You have to really enable the data scientists to view almost all data so that they can explore the data and identify patterns, etc. And then they can come out with the models that can solve the problem. Not only one problem that is identified, they will eventually bring in solutions with multiple problems as a byproduct of this particular effort. So the data governance, exposing the data as it is, whether it is to be, how do you really secure the data? How do you really make sure that not personally, all personally identifiable information or PHI or HIPAA, all these standards, right? Those standards based data are to be encrypted. They should not be shown in full form or half form, right? So those are the areas where the challenge is extremely high, right? So that is one area where all these leaders struggle to really execute the project. Okay, they can even take all the databases and put it into the Hadoop or anything, right? But the thing is, after building the data warehouse, securing them, making sure that only the people who are authorized to access the data, right? That level it is difficult. Okay, especially when it comes to data science, it is a real struggle, right? Okay, that is number one. Number two is, so many challenges. We can keep on discussing it for the next whole day also, right? The next thing, one of the thing is the data quality, right? Today's world, analytics and data science is not just tied to the enterprise data alone. The data that is produced within the enterprise, right? All these SAP systems, manufacturing systems, financials like Oracle financials, all these, and then the custom systems that are built inside the enterprise, right? All these things produce data from the enterprise. Many of the transactional data, like for example, take all these online e-commerce players, right? They generate data within them, right? All the online purchases are heavily controlled data with high quality, right? So far, the data that was consumed for analytics is confined by the enterprise boundary. That means like it is to an extent like 80, 90, 95% good quality data. They can trust that the integrity of the data is good, the data values that they have got for various entities are good, then they can proceed with their analytics. But today, the landscape has changed a lot. The data from external sources play a critical role here, right? That's the kind of analytics, right? Analytics is not like taking the production data from within the manufacturing unit or the online transactions from an e-commerce application, e-commerce players, right? It is not just analyzing the data within that boundary, right? What we do, we take the third-party data, we take data from various sources like weather, news syndication services, and then the market data, and then what we do, we derive a context, right? The context is what we are trying to build, and that is what is going to yield the insights. And on top of those insights, we are going to build actionables. Okay. Now the thing is, when you source the third-party data, systems data, or the data from the social sites, right? The data is not in your control, right? So what happens is, like when you source the data, the quality of the data has to be maintained by you. It's coming from some sources, right? So you have to really make sure that the data is of good quality, and then you have to process that unstructured data, convert it into structure, and then use it for predictive analytics or any other data science analytics, right? So there are too many challenges in that area. Okay, so these two are very critical area. There are so many other challenges, like finding the right talent in the market itself is a big challenge. Finding data science scientists is really a big challenge across the globe. It is not just India or US, it's across the globe, it's a big challenge. Okay.
Thanks. I think you brought about some very good points. Ganesh, I want to know your opinion on some of the points which were brought up about finding the diverse mix of talents and also around data quality. Can you talk about some of the challenges which you specifically faced in your organization, in your
Finding a talent is really a difficult thing. We need to have an array of resources that needs to be used. You have tools like you can always have a partnership with the external institutes, or else you can always train your internal members to that level. That is one thing. Another thing is, interestingly, when the offshoring started, one of the pioneers is Covances. What they did is they usually, at the time in 1999 and 1998, at the time there are no much BTech graduates or BE graduates. They usually hire BSc graduates, and then they have a strong internal education system, that is training department, that will train them into computer science and software development in those areas. Through that, they can able to leverage existing resource into a resource that they can use in the market. So that's one way. And the same model is even used by other non-technical companies like NTTF. They are actually an institute, but they went into the industry with their institute people, and they have a unique program that half day they will learn in the institute and half day they can work in a workshop or actual industry. That the quality of the education is such that TVS is one of the automobile industry. They are ready to hire those guys, those who are trained from that institute. So in this way you can, these are the pointers to solve this problem of a skill. And other than that, what else?
Just your views on the challenges you face with data quality and the data integrity.
That's the same thing I used. I have these ideas, and I usually spend around 2 hours for a new hire. Okay, so that way we have that way we can that way we used to source a talent outside. Daily we used to spend 2 hours for interviews alone, apart from my regular work, so that we can have we can source them from outside and have a pipeline of talent pool inside our company. That's the one way. And other than that,
so how do you ensure, so in your field, when you're working with software robots and everything, and you have to train them, and what kind of issues have you faced with the quality of the data and the or the lack of data, if you face such?
Yeah, the thing is that the quality of data and the quality of people, the quality of people is very low actually, especially in software robots and those areas. And then even the quality of data, in that way we don't find much data. So what we usually do is we at least create if we don't have a natural data, we create artificial data using simulations. Okay, that's one way to go about increasing quality of data. That we did for even connected cars also. For connected cars technology, while we are working, we don't find a data except US testbed data. So what we did is we created our own simulation software, and then we ran a car on the simulation software and continuously got the data out of it, and then we try to apply apply analytics model upon it. That is one way. That's the reason. See, if you want to have a good model, you need to have a experimentation bed, a test bed to you. Okay, so one way is to do with is simulation.
Thanks. Satya, you talked about getting the challenges, getting a buy-in from the leadership, and you also touched upon the resistance to change in an organization. So what are some ways that we can overcome these challenges so that organizations are more ready to adopt data science?
The best way is to be in their shoes on the business aspect. That's where our, as you saw, a couple of the job profiles were program manager, and everyone were talking, you need to know the business insight. And from my past experience also, it's always the business people who should drive the data science, data analytics, so that they can bridge the gap. And to be precise, even that kind of helped me out in last couple of years to sell the idea of analytics, is because of my pension background, I could talk in their terms. I could relate to them. I could go and see what is the SME deals about, and then explain how this can help them. Explanation on the detailed level, how it helps them, kind of solves that hurdle. And obviously, top management is a different story. You may have to come up with the numbers for them, how the best ROI, how it would be a better ROI for them. And I'm sure they are veterans in the industry, so they understand if you can give a proper business case. For example, like last week itself, I was talking about New York case. The project manager there was really awesome, actually, and Rajesh can vouch for that. So I took him out there. He knows concepts of data analytics. He has no clue what that is. He had heard the word data analytics for the first time from us. But somehow he grabbed the idea. He knows that it is a good ROI. Even for the matter of that, he was thinking, if I spend 50,000 on resources, 50,000 US dollars on like putting up the servers.
My perspective is lately I've been advising a cyber security company. A cyber security company is working for a Malaysian government, wherein they don't want to believe or they don't want to work with American companies or Israeli companies just because they are not trusting them, because Malaysian government is a Islamic government. They don't want to trust them. So that's the reason they came for us to implement a cyber security. Thing is that the fundamental mistrust about the company is a big barrier in accepting the big data technology that is given by other companies, right? And then the security point of view, in big data area, that is Velmurugan said that most of the tools are really a costly thing, but there are other open source tools also to apply on the big data. There are open source tools that you can tweak to apply in big data, like Security Onion, and then other companies also releasing open source tool in this area, like even Cloudera released a Spot, and then Hortonworks also released Metron. Those kind of tools are available, but it needs some little tweak to apply over the cloud environment. So if that is taken care, I think security wise we can easily have some improvement. So in that area, then after that, ROI on big data. Big data is relatively data science. Big data ROI people can easily see because of cloud infrastructure that is deployed. So that won't be that problem, I think, for a company to understand its ROI.
Thanks. We'd like to hear your opinion on how can we help companies adopt big data and maximize the return on investment, essentially, and how do we overcome, or at least how do we approach this problem and help companies adopt it in a better way?
Yeah. See, first and foremost, two different approaches are there. One is you define the problem, right? What problem you are going to solve using the data science, right? And then identify the things from top-down approach, right? That gives you a better ROI, right? Because you know what exactly the problem that you are going to solve, and you know what is the data that are to be used for that solving that problem, and you go and get their buy-in and then get things right. Here the problem with the ROI is the cost of executing the project, and big data and data science being more and more R&D driven projects, right? Like the technologies are there, they are maturing, but it's not like predictive analytics can be implemented using one algorithm called linear regression algorithm alone. So the predictive analytics is normally implemented by using multiple algorithms, okay, to solve one problem. So the approach itself is you define a problem, then choose the algorithms. Rather, don't go by the algorithms and then define the problem, right? You define the problem, then choose the algorithms and move the way forward. Like choose the data, then implement it, and then validate it, and then go. Okay, that is number one. So this is top-down approach. The second biggest benefit of data science approach is the bottom-up. Like a data scientist is given lots of data, the enterprise data, the market data, syndication services data, and so on, right? You give all data and allow him, give him a cool 1 week or 2 weeks or possibly a month. He will navigate through all parts of the data, right? He will vertically section it or horizontally partition it, look at all the data and combine, connect and correlate the data from different data sets, right? And then he will bring out newer insights that no one can think of, That's the biggest benefit of data science. The data scientists go through the data, correlates data from different data sets, and makes insights that you can't think through. Okay, that's the real biggest ROI. In fact, that will yield bigger ROI, but the predictability is very difficult. Predictability is tough. Sometimes, 80% you will really have better results. Sometimes you may not have. Okay, that's the part. Okay, so you have to be. Normally people follow first approach, and there are companies or leaders who encourage both approaches. Right? They have a ROI, predefined ROI to sell to their senior leadership team, back the project, back the funding, right, and start on the exploration also, and present a better ROI than what is given, right, to the leadership. That means the leadership is happier because they receive more ROI than what the leader has actually committed. Right, so that is one. So running the two tracks is really good, because the exploratory nature of analytics is going to give you more newer insights that you have not thought through. So that will really drive the leaders or CIOs or CTOs to probably build a new business model also. So those newer business models are built by using those insights, right? Okay, that is the approach from the ROI and all these things. One of the execution related issue, it is predictability of the delivery. Let's say like we are executing a Java based project to develop some services to capture the transactional data. It's all very predictable. Last 2 to 3 decades we have been doing it, right? We know everything, what to do, what not to do, where things will fail, where things will not fail. But when it comes to this data science and the big data projects, right, the predictability is very tough. In terms of, like, say I plan a project for 6 months, will I be able to deliver it or not? So now the leaders like CIOs, CTOs, and then the directors involved in the projects, right, they are all thinking through predictable execution models, something like factory model that can solve that problem, right? They build the infrastructure with software and hardware with lots of automation, and that can help deliver the intended data science projects or any other things, right, in a predictable way. If they predict for 6 months, it will be delivered, say 5.5 months or 6.5 months. So either advanced or a little later, but it is not something like where you stay at 50% of the project while you have consumed the entire timelines. So the predictability is very critical, and people will have, the leaders do invest their time on that. That's one of the major challenges. So they want to solve that problem. Okay.
Thanks. I think that was a very stimulating discussion about the challenges we face in organizations adopting data science, and we also saw some approaches on how to deal with these problems and how to approach this. And specifically, we talked about problems around data governance, data quality, organization agility, getting a buy-in from the leadership, and return on investment, the problem of actually showing a return on investment. And I think this wonderful panel also showed you guys some ways of tackling these problems and approaching these problems. So I think in the interest of time, I will open up the floor for questions. You can feel free to ask questions either to the whole panel or to any specific person if you choose to do so. So could we have the mic given to the audience for questions?
Science. So data science, unlike, let's say, the existing software building industry, you require ideas from many different fields, like from mathematics, from statistics and computer science and whatnot. So my question is, what would your ideal data science team look like? If you had access to all the resources possible, what would your ideal data science team look like? This is question 1. And question 2, relating to that, is what are you missing in this ideal from this ideal team? Yeah.
So I think let's start with you.
Yeah. I usually go with a solution architect, a technical architect with a data science from MBA background. If at all, if a company wants to do consulting, analytics consulting. So thing is that if its company is just doing analytics consulting, then data science with the MBA background is enough. If MBA has mathematics and statistics, but if a company want to translate that analytics model into a production environment, or if a company want to implement that as a real-time analytics, then you need a solution architect or technical architect. So that's the one way. Other than that, if it is a business, if you want to address a tough business problem, to translate a business problem into a mathematical model before going into analytics model, you might need a mathematics PhD or a statistics PhD on that line. And then 4 or 3 junior machine learning engineers who can able to apply model into a production system, okay, who are implementers of the production system. And then always another set of juniors, so that they can learn out of the team's experience to build upon. So this is the right mix that I think.
From my perspective, I want to stay in the business as much as possible, business side of the code. So definitely you need, even though we start with only small side of data analytics, we are very new into the field. I do like to have CMS or the IISc's folks into it. But with the constraints and other things, partnership, as Nelson put it perfectly, and Om is there for me to help me out. So to start with, at least to establish a data analytics concepts into the organization or to help anyone, definitely you need a very good business leader who knows the business, who can drive the whole thing. Data analytics, you would come only from one side of the code. That will never solve the issue. You have to have business leaders into it, and in the team at least. You need to know the business in and out. That's where business leaders do come into play. And that's this side of the code. From analytics side of the code, good statistical experience and academics helps them out. And a good team, the team would involve these two big players and obviously gel together to deliver the whole product.
Do you really need an answer from me? Because both of the gentlemen have covered almost all.
I would just like to add something. I think you guys covered some great points, but I would like to add, I think for a successful data science company, you need somebody to do sales and marketing and understand the domain, because otherwise you won't get the money to do what you want to do, essentially. So I think that's very important. And having a data evangelist, somebody who can think and experiment and has these lots of ideas which are ready to implement, and having a full stack developer to actually go ahead and implement that, essentially. And and I think everything else these guys have covered, but I would also add to the mix an applied statistician or machine learning, whatever you like to call it. So I see machine learning as applied statistics, essentially. It's the same thing. So some domain expertise, but I think the most important thing is a business leader, marketing and sales, because greatest ideas don't always win. So you need to make sure your great idea wins.
I think that you are making this statement from the product company perspective, right?
Company, yes.
Okay.
What component of the team is missing? What are you finding hard to find? Which talent is hard to
across the board, mainly the data scientists with PhDs and the statistics knowledge, right? That's the most difficult one. See, the expectation is changing today, right? People are moving from constructing a team with one project manager, 2 tech leads, 4 developers, right? That concept is gone are the days for those concepts. Today we are talking about individual contributors, right? So given that the data science project execution, right, or the paradigm involves right from mathematical knowledge or the numbers crunching, or when you see the number, you should be able to identify the nuances of the number, the characteristics of the data set as such. And then, just by visual looking at the table of data, right, you should be able to identify what are all the possible outliers, what are all the possible deviations, right? So such things are even possibly some of the patterns on the data. You should be able to visually identify. That's such an experienced data scientist or analyst is required. Okay, so finding them is very tough. And given the individual contributor role, right, that means all these data scientists are also expected to be tech savvy in terms of processing the data, transforming the data. In fact, most of the data science projects, right, 80% of the work involves processing the data for the respective algorithms or the suite of algorithms that build the holistic solution, right? So data processing is one of the skills that is very much expected. And then the domain SME, right? See again, it's a real brainy oriented job, data science. It's not like where we write program and see things, right? By looking at the data, you should be able to do. And then the domain centric knowledge is extremely important. If the same data scientist comes from the same domain and all, right, he will be able to apply the domain principles, the business domain principles onto the data, and he will be able to identify good data, and then the data that should be eliminated from this, noisy data and all, right? So those things are also very important. And for correlating, right, the even correlation is one of the critical aspects of the data science, right? For correlating events or from the data, right, you need to have the business knowledge also. So it's not simply technical where you just look at number and then make, I don't want to segregate, like say, there is a statistician, there is a domain SME, there is a guy who understands all these algorithms, and then three of them together will solve. I would probably prefer all the three together in three people, and all three put together solves the problem. So finding such talent is really, really a gap. Okay.
Thank you, guys. Hey, Savi, thank you very much. I won't get pink slipped because I'm a sales and marketing guy. And also, one more thing I realized here was that you data scientists, 80% of the time you prepare data and 20% of the time you crib about preparing data. Right? Now it's time for lunch. But before you go head for lunch, can I request Chidran sir to give a small memento? And lunch is 45 minutes. You want to come back in 45 minutes to hear Jagan speaking about practical use cases. Chidran sir. To Savi, to Vail, Satya and Danish. Thank you. So Jagan Ramaswamy has got some interesting presentation, so let's be back here in 45 minutes, please. Thank you.